Hi guys, today's lesson is on section 5.8, the rational zero theorem. The rational zero theorem helps to choose possible zeros, which are another word for solutions or roots of a polynomial, that we could test to then find other solutions or zeros of the polynomial. In order to find these possible zeros, every rational zero of a function is in the form p divided by q, where p is a factor of the constant term. The constant term is the term of a polynomial without a variable, and the q is a factor of the leading coefficient. Once we find p and q, we can then find all the possible rational zeros or solutions to the polynomial function. For example, problem number 1 through 4 in this page, we're just going to list all the possible solutions to a polynomial. First thing we're going to do is find p, which are all the factors of the constant term. In this case, the constant term is 16. So let's go through the factors or the numbers that would go into 16. That would be 1, 2, 4, 8, and 16. Let's now go through all the q's, which are all the factors of our leading coefficient, which is 4. All the factors of the number 4 is 1, 2, and 4. These are now going to help us create our list of all possible rational zeros. Those are in the form p over q. It's every possible p over q we could have. So I'm going to start with the first p value, which is 1, and divide it by all our q's. So 1 divided by 1 is 1. 1 divided by 2 is 1/2. 1 divided by 4 is 1/4. I'm now going to go to our second p value and divide it by all the q's. 2 divided by 1 is 2. 2 divided by 2 is 1. We already have the value 1 on our list, so we don't have to repeat it. 2 divided by 4 simplifies to 1/2. Again, we already have it on our list, so we don't have to repeat it. Let's move on to the p-value of 4 and divide it by all the q's. 4 divided by 1 is 4. 4 divided by 2 is 2, already on our list. 4 divided by 4 is 1, already on our list. The next p-value is 8. 8 divided by 1 is 8. 8 divided by 2 is 4, already on our list. 8 divided by 4 is 2, already on our list. The last p-value is 16. 16 divided by 1 is 16. 16 divided by 2 is 8, which is already on our list. And 16 divided by 4 is 4, which is already on our list. The list that we just created are all the possible solutions that we could have for our polynomial. Not every value on the list will be solutions, but all of the solutions are in that list, in addition to all their negative values. So the proper list that we're going to make, p over q, or all the possible rational zeros, all the rational numbers that could be zeros or solutions to the polynomial, would be positive and negative 1, positive negative 1/2, positive negative 1/4, positive negative 2, 4, 8, and 16. This is quite a large amount of possible values. On the second page of our notes, we're going to use this list to find a solution and then use that solution to find others. Let's go on to problem number 2 and just practice making this list of possible rational zeros or solutions to the polynomial. P are all the factors for our constant term, which in this case would be 12. The factors of 12 are 1, 2, 3, 4, 6, and 12. Q are all the factors for our leading coefficient in this case, which is 1. The only factor to the number 1 is 1, therefore our list for number 2 is fairly easy to make. All the possible rational zeros are all the positive and negative values of all the p values divided by all the q's, which in this case is literally just the p-value list. So positive and negative 1, positive and negative 2, positive and negative 3, 4, 6, and 12. What I'm going to ask you guys to do is use this idea to create a list of the possible rational zeros for number 3 and 4. Pause the video and then go ahead and play the video to check your answers. Here is your list for number 3 and 4. Number 3 is a little bit lengthy, such that all the factors for 10 is 1, 2, 5, and 10. And all the factors, or the q, for our leading coefficient of 3 is 1 and 3. Dividing all the p's divided by all the q's will give us our list here, in which we do have a couple fractions. When you have fractions that you cannot simplify in this possible rational zero list, you could leave it as the most simplified irrational fraction. And problem number 4, similar to problem number 2, q is just 1 since the leading coefficient is 1. So our list is basically just the positive and negative values of our p list, because everything in the p list divided by 1 is itself. Now, how are we going to use this list to now find actual solutions? These are all possible solutions. Let's now turn to our second page of our notes to find actual solutions of a polynomial using the rational zero theorem. Problem number 1, and now it kind of lists the steps here for us. We're going to find all the possible zeros, in which we're then going to test in order to find one in the list, and then we'll use those to find all the solutions, or all the zeros that the polynomial has. So let's go ahead and find our possible list. P, all the factors of the number 42. Which would be 1, 2, 3, 6, 7, 14, 21, and 42. That might take a little bit of guess and check on your calculator. And the q values in this case, which is just 1, therefore all the possible rational zeros, p divided by q, is positive negative 1, positive negative 2, positive negative 3, 6, 7, 14, 21, and 42. Out of these values, we have 1, 2, 3, 4, 5, 6, 7, 8. So technically we have 16 since it's the positive and negative values. Some of those are solutions to the polynomial. What we're going to do is use this list to check to see if we could find one. We're going to test a couple of these values until we find a zero. And then once we find one, we'll use it to then find the other zeros. So the first value I'm going to check, and usually your first solution is going to be early on in our list. We're not going to have to do that much checking. Let's check to see if 1 is a solution to the polynomial. How are we going to know if it is or not? How we're going to test it is using the synthetic substitution method. I'm going to substitute 1 into the polynomial, and if I get a remainder of 0, I know it is a solution. If I don't, then it will not be a solution. So I'm going to go ahead and list the coefficients of our polynomial here and really quick test to see if 1 is a solution. 1 times 1 is 2 to get -4, -4, -17, -17. Am I going to get a remainder of 0 here? No, I'm not. I know 1 isn't a solution. Let's go ahead and test 2. I'm going to go ahead and list our coefficients and use the synthetic substitution method to find if 2, or to test if 2 is a solution. 2 times 1 is 2, -4, which is -8, -13 and -8 is -21, -42. Sure enough, we get a remainder of 0, which means that 2 is a 0 or a solution to our function above. We can now use this, if you remember last section, to now find other zeros. We're going to factor our quotient here and find the remaining answers or solutions. So over on the side, our quotient is x squared minus 4x minus 21. Let's go ahead and factor that trinomial and then set the factors equal to 0 to find the other answers or solutions or zeros to the polynomial. Two numbers that have a product of -21 and a sum of -4 is -7 and 3. Setting those two factors equal to 0 and solving for their solutions or x values, we're going to get 7 and -3. How many zeros or solutions does this polynomial has? It has 3. X equals -3, 2 that I found by testing all the possible I just guessed and checked, and 7, in which when we're writing our solution set, you want to write them, the x values in least to greatest order. If we were to graph this polynomial, it would cross the x-axis 3 times at x values of -3, 2, and 7. Let's go on to find zeros for problem number 2, in which I'm first going to create a possible zeros list. Our p-values are the factors of our constant, which is -2, so that would be just 1 and 2. Q are the factors of our leading coefficient, in this case is 1. This list is going to be pretty short of possible rational zeros. P over Q is going to give us positive -1, positive -2. Out of these 4 possible zeros, we're going to guess and check until we find at least 1. Then we'll use that 1 to find other zeros or other solutions. Let's test to see if 1 is a solution, and we're using the synthetic substitution method. If we get a remainder of 0, I know 1 is a solution or a 0. I'm going to list our coefficients to our polynomial in which there are no missing terms. 1 times 1 is 1, -1 and 1 is 0. 1 times 0 is 0, -1 and 0 is -1. 1 times -1 is -1, -2. 1 times -2 is -2. Do we get a remainder of 0? No, we don't. Therefore, I know 1 isn't a solution to the polynomial. Let's check to see if -1 is a solution. Again, I'm going to list our coefficients, and you don't necessarily have to do this in order. Maybe some of you might have went to 2 to check if it's a solution. -1 times 1 is -1, add it, -2. -1 times -2 is 2, add it, we get 1. -1 times 1 is -1, add it, we get -2. -1 times -2 is +2, we get a remainder of 0. What does that tell us about the value of -1? It is a solution to the function when set equal to 0. It is a 0. It is a root. We can now use this to find other zeros or other solutions by now factoring our quotient and setting those factors equal to 0 to find others. The remaining polynomial we have is x cubed minus 2x squared plus x minus 2. There are 4 terms here. We're at no GCF. What method are we going to use to factor this? It would be grouping, in which my first group will be the x cubed minus 2x squared, and the second group being x minus 2. The first group has a GCF of x squared. When factoring out, we'll have x minus 2. And the second group, a GCF of 1, which when factoring it out is x minus 2. The factors here are x squared plus 1 times x minus 2. I'm going to set these both equal to 0 and solve for x to get my other zeros. My first equation here, I will subtract 1 on both sides to get x squared equals -1. Square root both sides, in which we're going to get x is equal to positive and negative I. The square root of -1 is I. And in the second, we're going to add 2 on both sides to get x equals 2. What does this mean for all of our solutions for the polynomial, or all of our zeros? Well, we want to find all of the zeros and identify how many rational and imaginary zeros there are. Well, I know that x is going to equal -1 because I tested it from our list and found out it was a solution. I know that x is 2. And the other 2 solutions is positive and negative I. We have 2 rational solutions, which are -1 and 2. And we have 2 imaginary solutions, which in this case is x equals positive and negative I. How many times would this graph, if we were to graph this polynomial or this function, cross the x-axis? It would cross the x-axis 2 times at -1 and 2. This solution, this polynomial technically only has 2 real solutions, but in addition also has 2 imaginary solutions. So on your assignment later on, if they're only asking for your rational solutions, that would be the -1 and 2. Please let me know if you guys have any questions